Hello everyone, and welcome to Geotab's Wildcard Wednesday. Thanks for joining us today. My name is Cameron Johnson. I'm one of the Learning Center trainers here at Geotab, and for today's session, we have electronic vehicle features in 1902 with Sarah Kerr. Without further ado, Sarah, take it away.
Great, thanks Cameron. Welcome everyone. So today's session, we'd love to get your questions, but we're also hoping to hear any feature requests or use cases that is not addressed by what I'm about to present. So get your thinking caps on and think about what you would like to see to better monitor and manage your EVs in your fleet. So I'm going to be asking that at the end, but happy to always get feature requests and have conversations with you just to learn your needs. All right, so I'm going to jump right into it. So what's coming for EVs in 1902? The first thing I'm going to talk about is we are going to show EV charging activity on the map. So I'll show you what that's going to look like. So here, this is the familiar map view. You see your sets of vehicles in the map view just like you would any other today. But now we're including information about what the battery charge percentage is, or the state of charge, the SOC, as well as the charging status. So the charging status is indicated by that little lightning bolt at the bottom here in the list to say whether or not your electric vehicle is charging in your fleet and what the battery charge percentage is. You can see it in the list as well as in the map view. So how is this beneficial? So some of the questions that this feature can answer are, you have a good bird's eye view of what's happening in real time. You can see who actually is charging, who needs to charge, they're running low, who has enough battery charge percentage to make it for the next trip. So if you're a very dispatch oriented fleet, this is a good way to keep a good eye on your EVs. Next is, like what I said, who's nearest to location and has enough range is also a feature. So the nearest button is still available as it is today, but we also present what the battery state of charge is. Okay, so some caveats to know about is today, this feature is in feature preview, and I'll talk a little bit about that at the end. But in the firmware that's available today on EVs, the state of charge, the charge percentage, is updated every 1% change, but does not update as nicely during charging, but that is planned for the next firmware version. So just a caveat there. So in the next firmware version, which will initially be available as beta, we'll have those real-time updates while the vehicle is driving and charging, so you can monitor and predict, okay, when is this vehicle going to be done charging? And the same for charging status. It is not real-time updated today, but we plan to do that for the next firmware version. So just some caveats there. All right, the fuel and EV energy usage report. So some of you may be familiar with the fuel usage report. We are essentially extending the fuel usage report to include electric vehicle energy consumption as well. So this is good for monitoring the consumption of gas as well as electric energy for your plug-in hybrids as well as your battery electric vehicles. Fuel used is now included. This is the list view that you may be familiar with today. So it has fuel used, but now we're including energy used. But what's more important here is this middle column. So you're used to kind of scanning and having your fuel economy available. Now you have your fuel economy available, but also we're introducing the electric energy economy concept, which essentially is exactly what you would expect. It is how much energy does the vehicle consume over the distance traveled. But there's a couple of different units that are available for you to choose from to view this information, and I'll go through them in a little bit. But just to say here in this example, we are converting electric energy used into the equivalent in fuel, so you can provide one comparable metric to be able to evaluate the performance of all your vehicles in your fleet. In this example at the top, this is a gas car here. It's getting 25 miles per gallon. This one is a plug-in hybrid, the next row down. It's getting 108, so that's getting better. But this one here, this last one, this is actually a battery electric vehicle. It's a Tesla Model 3, and this is getting close to 140. So you can easily see here how well your MPGE, as we call it, when you're converting your electric energy into fuel as a comparable metric, you can easily see and compare the performance of these. All right. So what are some of the questions this report can answer now that it includes electric energy is just like what I talked about. How well are my EVs performing? What is the electric range I'm receiving? So I'll talk a little bit more about that when I go into some units in a couple of slides. Is the electric range close to the promised range? So a lot of us, we purchase those electric vehicles. I expect to get, a certain number of miles on those on a full charge. Am I actually getting that? So what is the real world range I'm seeing in my fleet? And then how are my EVs performing in comparison to my non-electric vehicles? So we just saw a good example of that. The data I showed you in the last slide is actual real data from our own employee vehicles. So we're seeing some good performance differences between those gas cars and electric vehicles. Other questions are some things I hear about a lot is some fleets, they typically start with plug-in hybrids. So plug-in hybrids, you need to charge them, but they also run on gas as a backup. And a lot of fleets took a first step in electric vehicles with plug-in hybrids, which is great. But in some cases, the drivers aren't always remembering to plug them in, and they are mostly running on gas. So this report really kind of gives an indication of whether or not the battery is actually getting used, so they're getting plugged in, or are they just running on gas? So unfortunately, if they're just running on gas, they're not going to get that good performance we just saw. And there is a field that it is included in the Excel report. It's called percentage electric energy of total that gives that answer. So we just saw the list view, but there is more data it's a report like any other, the fuel and EV energy usage report. You can get more data in those views. So a new thing too about this report is we have now 3 economy values, and I'm going to clarify those, and hopefully it's nice and crystal clear for everybody. So the fuel economy value is the value that exists in the fuel usage report today. New in the MyGeotab 1902 release is that when it is displayed, it's for when the vehicle travels exclusively on fuel. So why do we do that? Why did we make that change? So the reason why is if the vehicle is traveling on electric energy only or on electric energy and fuel, such as a plug-in hybrid, it doesn't give an accurate read on just the fuel economy. It would provide a really positive fuel economy, but it wouldn't actually encompass all the energy that was required for that vehicle to travel. It would only be for the fuel in that case. So we do not calculate that anymore, but for your fuel cars today, it will continue just as it is today. Electric energy economy is the new one with this report. So this is the same concept I explained earlier. It's when the vehicle travels exclusively on electric energy, so the fuel use is 0. And the one value that I showed in the earlier slide comparing the performance, that miles per gallon equivalent, miles per gallon, was the total fuel and electric energy economy. So we're providing this as a single comparable value across all your vehicles in your fleet. So whether they travel exclusively on fuel, exclusively on electric energy, or for plug-in hybrids that could be traveling on both, it's always displayed. So what we do there is we actually do a conversion of any electric energy into fuel to provide that single comparable value. So that's what you want to look for now if you've got a mixed fleet of electric as well as fuel cars. Okay, hopefully that's clear. Okay, there's a few other fields I just want to talk through here in this report as well. So electric energy used, it is when the vehicle drives, how much energy is required to move the vehicle forward for propulsion, as well as auxiliary loads. So for heating and cooling as well as any other energy that's used. One thing to note though is while the vehicle is driving, some of you may be familiar with the concept of regenerative braking. So this is when energy is added to the battery while the vehicle is operating from braking and from other sources, but primarily it's regenerative braking. And electric energy used to move that vehicle forward is essentially the total energy that is used to move it forward, but also we can subtract the energy that is added to the battery while driving. So this value can be negative if you've got a lot of cases where you're driving down a hill, there's a lot of braking when you're going down your hill, you're not using a lot of energy. And this is something we've seen. So we just want to say This is new for electric vehicles. It doesn't happen for fuel cars. So we just want to call that out. So hopefully that's clear as well. And the percentage electric energy of total is that value that I talked about earlier. If you're just trying to understand, are my plug-in hybrids running primarily on gas? But it also can just simply be used across your full fleet. So if your fleet is transitioning to electric and you kind of want to look at that metric to show, okay, we're primarily running on electric energy versus fuel, you can look at that value. Okay, so I talked earlier about the units. So today you can select your fuel economy measurement value. Now we have a new one called electric energy economy measurement. So that's a bit of a mouthful, so I apologize for that. But it really is just when you're running on electric energy, this is the metric you can choose. So I have these MPGE values here that in that first row. So if you are already looking at your fuel economy in the miles per gallon, this is a great way to just go with that. And by default, your electric energy economy will be selected as miles per gallon E for equivalent, when you've already chosen your fuel economy to be MPG. So really this is, I talked earlier about the concept that we convert the electric energy used into the equivalent fuel. That's how we do this. We're using a standard EPA calculation to do that. So it's all standard calculations to be able to make that conversion for you. However, if you want to see if you're moving, you've got more primarily EVs in your fleet. There's not as many of you today doing that, but you can start looking at other units here. The kilowatt hours per 100 miles. We have watt hour per mile. These are the energy units per distance. Mile per kilowatt hour. So I talked earlier about the use case of I just want to know if the range I'm getting is close to the standard range. So this is where you can look at this value, for example, the miles that you're getting per kilowatt hour. You know what your battery size is, so you got to start with that. So what is the battery size on that electric vehicle? And then how many miles am I typically getting per kWh? And then from there, you can easily see what is the real world range I'm actually getting. So this is a good way to answer that question as well. Okay, the next one is the same. So I showed the US imperial units. For those of you who are in metric, we have the same available in metric. So the same available equivalent units. So for you, we have the liters equivalent per 100 kilometers, kilometers per liters equivalent. And then the same thing as for our US imperial, we have the kilowatt hours per 100 kilometers, watt hours per kilometer, kilometer per kilowatt hours. Again, that last one is the one you want to look at to see, am I getting the real world range based on the battery size that I have. So, okay, the next feature is EV charging report. So the EV charging really just, as you would expect, it is gives kind of a charging history for your electric vehicles. So today in Geotab, we have the fill ups report. This is kind of the equivalent concept, but for electric vehicles. So instead of your fuel cars going to the gas station, this shows a history of your electric vehicles charging. So you can look at different things here. You can look at by zone. This is a vehicle view by zone. So you can kind of look at where in your wider fleet are vehicles charging. If you're using zones at, say, different facilities that you have with charging stations, you can narrow those or corner those off using zones. The second column here is where, when, and how much the vehicles are charging. So that essentially gives the start and end time as well as the address. The how much is this last column here. I'll just skip over to that one and then go back to the others. So this gives your total energy that's being added to the battery from charging during that charging session. And at the top, that gives a total. So depending on what time range you select, it will do that tally for you. This column here is essentially these percentage values are the battery charge percentage or your SOC, start and end. So you start and then you end. So when you start charging, you were at 29%, for example, and this one ended at 99. So it didn't quite get to 100, but it stopped at 99%. And this value here, this 118, 129 miles per gallon equivalent, is essentially the total electric energy economy you're getting between charging sessions. So since the last charging, this is what the economy value I got. So that kind of gives a comparable value. You can see how that's changing over time in a quick view here. The last thing here to point out is when you click on this little icon here, it takes you over to the map and you can see the location of where this vehicle charged for this charging session. All right. So what questions does this answer for you? So like I said, you have a full charging history. You know what happened with that vehicle. If you're trying to troubleshoot why a vehicle has the charge that it has, for example, it's running really low when you thought it charged last night, you can look at that history and understand what really happened. You can know where your vehicles are charging, when, how much do the EVs charge, and also the maximizing the use of the PHE battery as well. So we talked about this use case before in the fuel and EV energy usage report, so I won't go over that one again. So really another question this answers is, how much energy am I consuming at my charging facilities? So if you're trying to understand how much energy is being consumed at your different locations, for example, where you're charging, you can have a summary view by zone. So you can corner off your charging locations, like I said, and you can just do a tally by zone over different time periods. So it kind of gives that idea. So what's the EV contribution to building load, for example? Okay, so I want to talk about some core concepts here. So there may be some of you that use managed charging or plug sharing during charging. So what that means is, your vehicle stops, you plug it into charge, and your charging may start and stop until the full charge is done. So either by a managed or load management charging scenario, or if you're actually physically changing plugs around. So in that scenario, we kind of built this report in mind. Some of you may already be doing this. Several of you may be transitioning to this future. So we essentially, to make it easier to read the report, we do include every single charge event, which is exactly what you would expect. It's when a charging starts and stops. But we also introduce the concept of a charging session, where we're essentially group multiple of those charge events into one charging session during a stop. So this provides a more readable view when you do have load management in place. So for those of you who are a little bit more visual, I have a visual explanation of this as well, hopefully to get this point across. So your vehicle stops to charge. So here's two examples of two stops. During the stop, you have multiple charge events that happen, meaning your power is non-zero to zero during the stop because of a load management introduction. It will group multiple of those charge events into one charge session. So in this first example here, those 3 charge events are grouped into one. So you would just see it as one charge session that would start at the very beginning of the first charge event and end at the last one. Okay, now we'll go through some fields as well, just of data that shows up in this report. So some of it's pretty basic: start date, end date, and the duration. The location, zone, and zone type. So we are bringing in zones here, so you can easily look at how much energy you're consuming by zone. This report does adhere to privacy mode as well. So if that's a feature you take advantage of, it will blank out the location, zone type during privacy mode. The start and end EV charge percentage. So what was the start when you started charging? What was that battery start EV charge percentage? And what was that value at the end? And the electric energy added, that's essentially what you would expect. So how much charging was energy added to the battery during that charge session. And the max power, so the max power here, this essentially power versus energy is something that, if you're new to EVs, these are concepts that you're trying to get your head around potentially. Energy is that volume metric of how much energy, electric energy was added to the battery. Power is the rate at which it was added. So it's the kilowatts and not the kilowatt hours. So kilowatt hours would be the energy, kilowatts would be the power. And the higher your power is, the faster your energy is being added to the battery. So we call out the max power because sometimes there is fluctuation, especially if you're taking advantage of the rapid charging or the DC fast charging. You may have different names of it, but it's really that very fast charging that you may have available at your charging depots today or on the side of major highways, interstates, etc. And the maximum is, we've found from all the data we've looked at, is the best indication of what the sustained power was throughout the charge, even though there may be slight fluctuations. And then the current, AC or DC. So without going into too much electric geekery here, AC just means you're using a wall socket typically, or a charging station that you may have available. DC is the very rapid charging. So that's when the energy is being added directly to the battery and not going through an onboard charger. And AC voltage. So for those of us in North America, this will change. We have the option of the typically 120 volts AC, which is your typical wall socket. However, you may have a charging station that you have at your fleet depots, which is kind of the a little bit faster but still slower charge. That's usually 240 volts. But for those of us outside of North America, this is probably going to stay around 240 in that range. Electric energy economy, I talked earlier about how to compare between charging sessions. That value, we also bring that into the report just to see a comparable value that's already calculated out for you. Okay, so there are some additional data diagnostics. So these are available for you doing advanced reporting, so using engine measurements, and exception rules can be created based on these as well. So some very basic ones, I'll go through the core today, but I'll also link off to a reference where you can see more information here. So just whether a hybrid or electric vehicle is detected. I should have started the presentation saying in Geotab, we consider an electric vehicle a vehicle that plugs in to charge. So that can be both a full electric, meaning it's a battery electric vehicle. It does not have any, it does not run on gas at all. It also can be a plug-in hybrid electric vehicle. So you plug it into charge, but it can be running off of the high voltage battery or gas as a backup. We typically don't call a hybrid, a conventional hybrid that does not plug into charge, an electric vehicle. However, this data diagnostic is true for any of those scenarios, including conventional hybrids that do not plug in. The generic state of charge, this one is that battery charge percentage value. So this one is a really core one that you could probably create a number of custom exception rules off of. There is some advanced technical information there that I'm happy to go in if people have some questions around that. But I talked earlier about how there's a 1% change while driving today. And in the next firmware version, there's going to be a 1% change while driving and charging. All right, so driving energy. So I talked earlier about regenerative braking and how this value can be negative. So if you're looking at engine measurements, you're trying to figure out what these data diagnostics mean. The first one here, it's got a long explanation, but it's the total energy going into the battery from regenerative braking while driving. And this is the one where energy is leaving the battery while operating the vehicle. And when you see electric energy used in that fuel and EV energy usage report, it's really a calculation of out minus in. We're essentially using as two data diagnostics to create that calculation for you, and that's how the value can be negative. And there's an explanation there. Okay, we're almost through these ones. Charging energy core. So this is another one, is the electric vehicle charging. 1 equals charging is just as it describes, is the EV actively charging. True or false? EVs are on a firmware version, major version 25 today. And this will be no longer populated. This one is no longer populated as of the next firmware version. So just so you know, it's if you are getting into the data diagnostics and you're using these ones, there is a new one coming up for the charging status, and that's this one, electric vehicle charging. So it has a few more advanced qualifiers here. So it's 0 if it's not, 1 if it's AC charging, 2 if it's DC charging. So that's the only difference, and it's not going to be populated. So it's more of a heads up if you're using this one. And just so you know, I went through the core ones today just to kind of look at a high-speed view, but there is a data diagnostics user guide for more definitions and any availability limitations if you want to use those data diagnostics in the future. Okay, so custom exception rules. So I talked earlier how we can use those data diagnostics for that engine measurements report to look at advanced reporting. We can also create custom exception rules now. So some key questions you can answer with these ones is you can figure out who needs to charge, so get notifications when that generic state of charge, the battery charge percentage is running low, when a EV is getting full, for example. And another use case I've heard a lot of is some of you have high price differences during your day for electricity, so you want to make sure that EVs are not charging during those peak times. So you can also have exception rules around that as well. So those are just a few to get you started. So I've gone through kind of those new features. Now I kind of want to give a little bit of caveats on availability and EV data support. It is something we're actively building out all the time, so we kind of want to explain some of that here. So there's really 4 conditions to know whether your electric vehicle is supported. So the first is Go 7, 8, or 9. There are some differences that I'll explain really quickly between the data that's available on Go 7, Go 8, or Go 9. If you are using third-party devices, unfortunately, we do not have support for electric vehicles today. Electric vehicle make model. So very much, I would say that electric vehicles don't necessarily use the same standard data to access this data. So we essentially, our team works very hard to look at every single EV and make sure it's supported and making sure we can read the data off the right places. So whether or not your electric vehicle is supported is dependent on whether or not we say we have support and on the firmware version that you're on. So we do make that available in an EV make model support reference that you get that's linked to from here that you can go to and check, for your specific EV make model that you have in your fleet, what kind of support do we have? The firmware, so the firmware is the actual, software on the Go device that will read that data. So depending on what firmware version you have, so again, version 25 is what we're really talking about today, but our team is already actively working on version 26, which will be available in beta first. So if you're really keen to start accessing that data sooner, you can request the beta program, and I will talk about that in a minute. And the last one is that all of the EV specific data is going onto the ProPlus plan. But if you already have the Go devices in your EVs, you are grandfathered in to continued EV support. And that grandfathering happened mid-May. You may not have even known that it happened, but it basically says if you already had devices in your electric vehicles up to about mid-May, you are going to be grandfathered in to continued EV data access, everything we're talking about today. As long as your EV is supported on the device going ahead. So that is a thing I'll talk about too. But any new installs, you need to be on ProPlus to access this data. So I'm going to talk a little bit about that. So one thing about that first condition I talked about is the differences between Go 7, 8, and 9. I really want to call out there are no major differences here. So we're basically saying what's available. The one exception is that very last row at the bottom is that if you're on Go 7 or 8, you will see your EV charging history, but you will not see, unfortunately, the energy added from charging, as well as that max power value I talked about, as well as your AC voltage. So in some circumstances, that may or may not be important for you. but that is fully available on Go 9. Another difference here is what's in this blue bar is that essentially you can think of it as we did a lot of support on Go 7, Go 8 for existing make models, but going ahead, we'll be supporting most future make models on Go 9 only. So just to let you know, our future is very much Go 9. There is actual more code space there for us to work with. So we have more room to invest in the firmware on that device to support EVs. Okay. The next part is there's certain features that are only available in feature preview. So feature preview, some of you may or may not be aware that it's something that we have. So you essentially select, you can select this as part of your personal options. So here I showed how you would do that. The first step is in the top right-hand corner when you log into MyGeotab, you essentially select your name. And you see some options. You see this button called options, click that button and scroll down, and at the very bottom you'll see this switch called feature preview. So turn that on, and then you can see these features once they are available, like once you have 1902 in your database. So the two features that need feature preview to use them right away are the map with EV charging activity and the EV charging report. So we are essentially releasing them first as feature preview in order to work out the kinks and to make sure the firmware gets a little bit more robust. And then we'll be releasing them more widely outside of feature preview. Okay, so I talked about the EV make model support. There's, we're growing that support list every day, but you can reference that. I showed you the reference here, how to verify support. But if you don't see support for your EVs yet, but you would like to start using these features in near term and want to, especially if you're interested to give us feedback, anything like that, just try them out before they're released more widely. We do have an EV beta program. You can enroll in that beta program at any time, even if your EVs are supported, but the real benefit is you would have access to the EV charging data. Specifically, that is what's not going to be available right away. So you can get the full charging energy, the full picture of the charging data. You can have, if your EVs are not yet supported in the version 25 of the firmware, then essentially the next version of the firmware, you'll have your EV supported. If you're not really sure about whether you want to go ProPlus for your EVs, so we'll also grant you temporary access to the ProPlus without actually jumping into paying for ProPlus. So we'll give you 5 EVs for 2 months, and you can test out, what you would get with ProPlus. And myself, I'm an EV product manager, so I'm the one that's responsible for making sure these features work for you and we're prioritizing the right things for your EVs. We also get feedback on how we can improve these. So I'm always keen to get your feedback. Even I've asked for use cases today, if you can think of any that we don't yet support. So that's part of the beta program too. Okay, I talked about EV grandfathering. So a few of you with devices in your electric vehicles potentially had your EVs grandfathered. So just so you know, like I talked about, EV reporting is going to be under ProPlus, but if you're not on ProPlus with your EVs today, but you had those devices plugged in, you're going to be grandfathered into EV data continued support. So what is under ProPlus is essentially what I talked about today. Things like GPS, odometer, etc., that are available under other plans for all vehicles are under those same plans. You don't need a ProPlus if you're just looking for basic data off of your electric vehicles without what we're talking about today. So another thing is the grandfathering is for continued access to current and future EV data reporting, as long as it is available on your device. So for example, what I talked about is if there's some things, and we know there are, that are only available on Go 9, but you did not have a Go 9 in your device, then grandfathering will not apply for that all of the future potentially. So that is a bit of a caveat there. So for more information, there's a lot of new documents for you here. So we have a user guide. So that goes into a lot of more information about each feature, goes more in depth than what we covered today. The make model support reference, just to check what is available for your specific EVs. The data diagnostic user guide, so that's if you want to dig into more advanced reporting, you can see what all those data diagnostics mean. The beta program, if you're interested in learning more about that and signing up. And you've had some EVs that were grandfathered in, you have some questions, there's an FAQ for that as well. So lots more information. And something I said at the beginning, if you've got additional feature requests, anything that came to mind after hearing about this, I'd love to hear that today as well, but more so your questions too. So with that, I'll turn it over to Cameron for any questions that I can answer.
Awesome. Thank you so much, Sarah. Looks like we do have a few questions here. The first one we have here is, can you further clarify how electric energy consumed can be negative?
Yes, so this one is, you know, it's sometimes confusing and people look at that and they think there's an issue. If you're, especially for trips where you're not consuming a lot of energy, for example, picture a vehicle that primarily went down a long hill the whole time. It consumed very little energy, very little was required, and you were potentially braking a lot during that time, just to keep a steady speed. So you're adding more energy to the battery in that case than consuming. And we essentially calculated by everything that was consumed, but subtract everything that was added. And therefore, that's where you get the miracle negative value.
The next one here we have is, are there any conditions which disable EV grandfathering?
Yeah, so it will never get disabled from the device that it's on. So grandfathering is applied to the device. So if a device was plugged in an electric vehicle as of mid-May, it will be grandfathered in. If you move the device that's plugged into that electric vehicle to any other vehicle, grandfathering will continue, but on that device. So if you put in a new device into the original vehicle, there's no more grandfathering because it applies only on the device that it was plugged into, the vehicle. And then other things to know is just with Go9. If you did not have a Go9 device, and most of us didn't, Go9 is still new, then you won't have everything you need on the EVs on Go9. So it's a little bit of a caveat there.
Right, gotcha. Can you explain the differences between a charge event and a session?
Yeah, so that was a little bit complicated. So again, if you don't use load management, so load management means you've got, you know, potentially power restrictions coming into your facility. You're using specific charging stations that support that feature that essentially try to balance out the load of power going to multiple cars at once and bring down power to zero to some vehicles. Then you won't need this feature. You will need it in the future once you do have load management. So not all of us will get there right away, but it's a very commonly used feature once you have more and more EVs charging at once. You can just picture it as you plug in your vehicle to charge. The charging actually starts and stops multiple times during the stop. And charging session just says, okay, doesn't matter how many times you started and stopped your charging. From your perspective, you just care that it charged and you want to know when it started and stopped. So that charge session concept just brings everything together into one charge session versus multiple individual little charging events that could have happened, but we still present both information.
Sure. Regarding energy out, do you provide the details, meaning energy consumed for the motor or auxiliary? If so, is that able to be tracked via like AC or heating?
Yeah, so this is actually, it's an interesting question. The answer is we do not do that today, but I would love to hear, you know, how that information would be beneficial because we've got that request before. It is something that it's not 100% untechnically feasible. It's just we don't do it today. So I'd be curious to hear a little bit more about, you know, how that information would be valuable for you.
Awesome. Can you calculate your own charging costs with this information?
Yes. If you're just using the kilowatt hours consumed for the charge event, you can do that easily if you're on a flat rate, and not all of us are on a flat rate. So for example, if your charging costs per kilowatt hour are the same throughout the day at a specific location, you could just multiply it, right? So for all charging that happened within this zone, this was the price at this facility per kilowatt hour. It's not super easy to do it if you have fluctuating prices, but that's something we want to offer and make it easier in the future to be able to break down pricing so that it can better match the different changes in your rate throughout the day and be able to provide that for you. But it's easy if you have a flat rate, not as easy if you don't. We hear that request all the time. We want to make it easier for you in the future.
Awesome. Well, we had a lot of great questions. Looks like that's going to be a wrap for this week's Wildcard Wednesday. Again, I want to thank Sarah for joining us today and presenting for all of us. I also want to thank all of you in attendance for taking the time to be with us. Until next time, I'm Cameron Johnson, and on behalf of myself and everyone here at Geotab, I want to thank you for joining us today on Wildcard Wednesday and wish you a productive and profitable week. Take care.